So hello all. So we have been discussing about this biomimicking robot. So in fact, this is a kind of a last module which I have been discussing. So we had discussed about the various functionalities related to these bio-inspired micro robots. Especially we are focusing more on the locomotion related aspects. Like we have been discussing about the mechanism related to flagellum for micro robotic related applications, how these are being employed. So then we have also discussed some of the different key functionalities with reference to this locomotion mechanism, which includes flagella based, then cilia movement based, then insect like walking and jumping, then a jellyfish and a soft body based motions which are being exhibited. Then when we try to talk about the sensory and the perception, so it basically talks about the compound eyes, about the electroreception which is available, and then there is a tactile sensing which is being deployed. Then we also had some discussion about the energy and related actuation. Now we are more focusing towards this Gecko inspired climbing robot. So in fact we have been discussing about this micro and nanoscale Gecko inspired system. So as far as these Gecko inspired climbing robots and about the overall functionality. Now let us discuss about the different mechanisms which are involved in this Gecko inspired climbing robot. So as far as in this Gecko inspired climbing robots are concerned, so these Gecko inspired, so if you try to look into the functionality of this Gecko inspired climbing robot, like these robots can operate at a kind of a vertically oriented surface which allow the possibility of tasking. So in fact, like if we look into the if we closely observe the kind of adhesion mechanism which is being deployed, so we have classified these adhesion mechanisms. So like there are wide varieties of researchers who have discussed or who have studied about this adhesion mechanism. So most of the common type mechanism, adhesion mechanism, is the suction adhesion, where the robot carries an onboard pump or to create a kind of vacuum inside the cup which are pressed against the wall or ceiling. So this type of like suction mechanism has a kind of a major drawback. So the suction adhesion mechanism requires time to develop an enough vacuum to generate a sufficient adhesion force. So this delay may reduce the speed at which the robot can locomote. And another issue associated with the suction adhesion is that any gap in the seal can cause the robot to fall. So that is considered to be one of the key drawback of this system. Like in this drawback, it limits the suction cup adhesion mechanism to relatively smooth, non-porous and non-cracked surface. Lastly, the suction adhesion mechanism relies on the ambient pressure to stick onto the wall, and therefore it is not useful in space application, as the ambient pressure in space is essentially zero. So another common type of adhesion mechanism is a kind of a magnetic adhesion. So these magnetic adhesions has been implemented in a wall climbing robot for a specific application such as nuclear facility inspection. In specific areas where the surface allows the magnetic attachment can be highly desirable for its inherent reliability. Despite that magnetic attachment is useful in specific environment where the surface is ferromagnetic, so for most of the application it is unsuitable choice. So in fact there are wide varieties of researchers who have discussed this, who have designed such kind of these suction mechanisms, like kind of an unconventional attaching. So which is inspired by climbing, and new strategies can be developed for use in climbing robot. In fact, many animals have the desirable ability to stick to the climb or various surface, like insect, beetles, skins, anoles, frogs, geckos has been studied to understand the mechanism, especially with respect to its sticking capability. So in particular, when we try to look into these geckos, the geckos are most interesting because of their size. So that let us consider a kind of a gecko called toque gecko. So you can just refer. So these Tokay gecko can weigh up to 300 grams and it reaches a length of up to 35 centimeter. Yet it is still able to run and inverted and cling to the smooth wall. So, and by studying and imitating the attachment mechanism of this gecko, a new generation of robots can be developed, making the locomotion possible. It is in almost any kind of surfaces without contaminating the environment. In fact, when we try to look into the different types of adhesion mechanism. So one adhesion mechanism is called as a dry adhesion. We had discussed about it. So, and then the other type of mechanism is called as a elastomeric adhesion. And then we have the elastostatic adhesion, and then there is a thermoplastic adhesion in place. So let us discuss one by one about the mechanism which are involved in this adhesion process. Now, as far as these dry adhesions are concerned, so these dry adhesions, it works on the principle of the van der Waals force. Now, when we try to closely observe how does these geckos work with reference to dry adhesion, so these geckos, our feet are covered with millions of microscopic hair-like structure, which is called as a setae. Okay, so which we had discussed earlier also. So each setae branches into 100 of nanometer sized spatulae, so which we had discussed earlier. In fact, we have seen the structure where there will be a kind of a microfiber and a nanofiber which is being integrated in this region, and it has an increase in the contact area. These spatulae interacts with the surface via a van der Waals forces, which are weak but cumulative when applied across millions of spatulae, resulting in strong adhesion. So the adhesion is directional, meaning it can be turned on or off by adjusting the contact angle. As far as this mimicking perspective point of view, these synthetic gecko adhesives are made using materials like PDMS, carbon nanotubes to replicate the nanoscale and the adhesion effect. So these materials are structured hierarchically from micro to nanoscale to mimic a natural gecko adhesion process. So by designing the foot pad with the controllable orientations, robot can grip and release the surface on demand. So suppose if it is trying to fit onto this surface, so it can hold, it can create a suction. This suction is capable enough to hold the complete payload, and then appropriately by releasing the suction, it will be loose. So by alternatively giving this suction mechanism, a climbing can be appropriately initiated. Now this is a kind of a schematic representation of a climbing robot. So in this climbing robot, so here if you see, a gravitational force is in this particular orientation. So we have the first adhesive foot, the second adhesive foot, then there is a vertical structure in place, and then there is a tail structure in force. So the suction mechanism what we had discussed earlier will happen alternatively between this first adhesive foot and the second adhesive foot. So appropriately what happens is there is going to be a contact and a separation which exists. This contact and the separation will be helpful for this particular robot to climb against the gravitational force, and it will also be helpful for the system to, it will be also helpful for this structure to pull the tail towards a particular direction. So in fact, this is a simple schematic representation of the structure. Now let us discuss about the models which are involved in this gecko inspired climbing robot. So as far as in this when we try to closely observe the model, so these model basically explain the design requirement. So that is, so you have a kind of a structure where there are certain amount of all distinct microstructures are there, which is in the form of an adhesive. So here if you see, like based on the suction mechanism, appropriately if we try to notate it, so there will be a different forces which exhibits. The resultant of these forces is the outcome which is represented over here. So like it's a kind of a different suction cups which are being placed. These are kind of a micro suction cups. These micro suction cups will try to interact with the a surface, and then it will try to induce a kind of a suction, and from the suction we can observe the overall moment or the overall resultant force which exhibits. Now let us discuss about this particular model which is involved in this gecko kind of arrangement. So this model is called as a kind of a it's a kind of a proposed model where in this particular case there is a kind of a rigid tile kind of arrangement is there, then there is a kind of a compliance support and a tile tendon which is available. So this is a kind of a structure. This over this structure there is a kind of a pressurized sac which is available, and then there is a pressurized plate. So this pressurized plate is made to move back and forth. So when this plate made to move back and forth, we have a pulley kind of arrangement, and then we have a main tendon kind of arrangement, and then there is a rigid tile, and then there is a complex compliance structure which is available. So the moment of this pressurized sac is appropriately transferred to this compliance structure, and this moment of this compliance structure will create a kind of a adhesion mechanism over here. So the overall mechanism is controlled by the pulley, as well as the overall mechanism is also controlled by the main tendon which is available over here, and then so appropriate movements are monitored over here. So this compliance structure is slightly flexible so that it can create a kind of a pull and push kind of arrangement. These rigid tile are kind of a support structure which will be involved for the movement in a climbing fashion. Now let us discuss about the next level mechanism, which is called as a elastomeric mechanism. So as far as these elastomeric mechanism is concerned, so this is it has a two structure layer. So this is a kind of a base which is available, and this is a kind of an elastomeric attachment which is available over here. So let us consider this as a soft flat elastomer with a radius A and thickness T. So there is a kind of Wittler flux elastomer which we are notating it as E. It is mainly meant to create a kind of a smooth surface S. So when a compressive load sigma C is applied, the attachment of the Wittler flux elastomer to a rough surface Y with an amplitude H and a roughness and the wavelength lambda. So the detachment process of this Wittler flux elastomer form a smooth surface when a tensile force. So when a tensile force Fp is applied. So this detachment process of this Wittler flux elastomer from a rough surface when a tensile force Fp is applied. So ideally what is happening is, so we are trying to apply an attachment and a detachment process with this Wittler flux elastomers, so that there is going to be a kind of an elastomeric adhesion which is going to be exhibited over here. These elastomeric adhesion will be helpful for appropriate movement in the system. So if we closely observe the different parameters which affects this particular system are, one is the thickness, then another one is the kind of a wavelength, and then amplitude, and it also depends upon the force which is applied on it, as well as which is noted as Fp. Now let us take the other mechanism which is called as an electrostatic adhesion. So as far as the electrostatic adhesion is concerned, we are well aware about this comb drive actuator. So almost here also it works on the same principle. So it has a kind of a hybrid adhesive anchor which is being kept over here. So here if you closely observe the metal process, the fabricated process of fabricated hybrid adhesive anchor, a metal is deposited giving the required electrode shape on the substrate, which constitutes the section 1, the section 2 and the section 3. So a layer of PEN film over the positive electrode acts as a kind of an insulator. Putting this Gecko inspired adhesive on the front surface finisher, the adhesive pad, which consisting of 4 and 5. So this fabrication of this full anchor is achieved by employing a kind of a foam backed magnesium bracket, which is shown over here as 6 and 7. So what happens is, we have a mechanism, and then there is a 4 and 5 which is being placed over here. So which is a kind of an adhesive pad which is helpful for an interaction to create a kind of a electrostatic structure. Okay. Now let us discuss about the third mechanism which we call it as a thermoplastic adhesion. So as far as in this thermoplastic adhesion structures are concerned, so there are if we closely observe in this, so there are certain amounts of pellets which are available. So these are called as thermoplastic elastomers, which are formed by the thermocompression modeling. So these thermoplastic elastomers lying on a glass slide, which is melted using a slide pressure, which forms a kind of a TPE melt, and the silicon mold is placed on the single SESB TPE melt with the desired force. So the silicon mold and the glass slide are removed from the hard plate and it is allowed to cool. Later the TPE adhesive fibers are formed. So as far as in this particular case is concerned, so we have a TPE pellet in place and then there is a glass slide with a hot plate, and the TPE pellet will be capable enough in such a way that when there is a kind of a force which is exerted, appropriately we get a single TPE melt. Now when you try to apply a uniform pressure on this, which is in the form of a single silicon mold, the silicon mold will take a shape which is a kind of a TPE adhesive fiber. So these kind of structures are deployed for kind of an appropriate adhesion or for an appropriate locomotion. So these are called as a thermoplastic adhesion. Now let us discuss about the locomotion mechanism of this Gecko inspired robots. So as far as when we try to closely observe the locomotion mechanism, to climb effectively, this robot must distribute their weight and control movement and detach their feet without slipping. So there are various locomotion strategies are included. One of the locomotion strategies include the leg climbing. So as far as in this leg climbing is concerned, so there is going to be a kind of a gecko-like movement which uses a 4 or more leg to distribute its weight. It also has a kind of a foot pad which are designed to apply and release the adhesion in a control sequence. It mimics the Gecko gait cycle where at least 2 feet are always in contact. So like let us consider there are 4 feet are there, 2 feet will be in contact and 2 feet will be helpful for the propulsion. So appropriately there will be a release in the suction and then there will be a kind of a forward displacement which can be observed over here. Now let us talk about the rolling and the sliding motion. So in the case of a rolling and a sliding motion, instead of leg, some robots uses a continuous tracks coated with the Gecko inspired adhesive. So these rolling mechanisms allow a smooth adhesion and a detachment as the robot moves, and it is used where a rapid climbing is needed. So in this particular case, the rolling mechanism allows a smooth adhesion and then there is going to be a detachment which is going to be appeared over here. When we try to talk about the suction type Gecko hybrid climbing, some robots combining these Gecko inspired adhesives with suction mechanism for improved grip on rough or curved surface. So when we have a suction mechanism, so there is going to be a suction which is going to be exhibited over here, and appropriately there is going to be an improved grip which we can observe in this suction gripping mechanism. Now let us see some of the commonly used Gecko inspired material for such kind of adhesive fabrication. So the first adhesive which is being effectively used is a PDMS structure. So these PDMS structures has an advantage which it has a high elasticity, it has a easy curing, and it is cheaper also. However, with reference to disadvantage perspective point of view, it has a low productivity and it has a bending problem. As far as application perspective point of view, it's a kind of it is mainly meant for a certain amount of wall climbing robots, etc. Then with reference to PMA perspective point of view, it has a high mechanical strength with easy applications. Now the major disadvantage which is observed over here is it's brittle and it is widely used for a kind of a climbing robot, and it is also used for grippers. As far as PS is concerned, so it has a kind of a high aspect ratio which has a low surface energy and a limitation of accurate replication, and it is mainly meant for some kind of medical adhesives also. As far as PVS perspective point of view, it also provides a similar mechanical properties as that of Gecko in the low environmental sensitivity, and it is complex to prepare, and it is widely used for different robotic applications. As far as PE is concerned, it has a high aspect ratio, it has a low surface energy, and it has quite a good amount of biomedical application. and PP is concerned, it also has a high aspect ratio and it has a low surface energy. It is widely used for climbing device related applications. With reference to PU, which is a kind of a polyurethane, which it also has a high surface energy, it has a long curing time and it has a legged robot. With reference to silicon perspective point of view, it is easily available and durable and high quality. It has a poor clear strength and a space equipment. And a CNT perspective point of view, it has a high mechanical modulus and high aspect ratio, complicated, costly, and it is a highly preloaded structure. Application perspective point of view is concerned, it is mainly meant for a different healthcare monitoring related applications are some of the key applications of this system. So in fact, if we closely observe, these are some kind of wide varieties of adhesive based materials which are used for fabrication. The selection of these materials ideally depends upon the type of mechanism which is deployed and under appropriate applications. Now let us see some of the applications of this Gecko inspired climbing robot. So as far as these Gecko inspired climbing robots are concerned, it is used for inspection and maintenance. So these climbing robots for inspecting building, bridges, wind turbines and spacecrafts are some of the key applications of these kind of climbing robots. Sometimes it is used for search and rescue operations, that is the robot that climb the collapsed structures to locate surveyors. So basically it can be used for surveillance and it can be used for identifying a particular person. So basically it can be integrated with a camera for a kind of a face recognition system, can also be deployed in this particular structure. Then it also has a potential application towards medical. So basically, like wherever we have a kind of a miniaturized based climbing robot for endoscopic procedures which inside the human body can be easily deployed using these kind of structures. Then it has a potential application in space exploration. So in fact, NASA has tested a Gecko inspired adhesion for robotic arm and for a kind of a zero gravity climbing robot where such kind of space explorations are explored. Military and surveillance, because since it's silent and a wall climbing robot for spying and patrolling related applications are some of the key applications which can be explored. Now when we try to look into the challenges perspective point of view, it has a limited load capacity, it has a multi-layer adhesive and better weight distribution, and a surface roughness perspective point of view, it is flexible, it is adaptable, and the adhesive that conforms to the kind of an uneven surfaces can also be explored. With reference to dust and with reference to contamination, it has a kind of a self-healing adhesive surfaces which are inspired by this Gecko natural cleaning ability. And a soft actuator perspective point of view, it has a kind of a detachment control where we have a kind of a soft actuators in place which is mainly meant for kind of a directional peeling based mechanism. So these are some of the different applications of this Gecko inspired climbing robots. Now to summarize, we had discussed about the overall functionality of these Gecko inspired climbing robots. Especially this acts as a base for establishing such kind of Gecko inspired climbing robots. We had discussed about the different subsystems under these Gecko systems. So we have also discussed about the different mechanisms which are involved in such kind of Gecko inspired climbing robots. So we have classified these mechanisms involved into 4 different categories. One is called as a dry fibrillary adhesion based system. Then there is a kind of an elastomeric adhesion which is being contributing to it. So we have also discussed about this electrostatic adhesion and a thermoplastic adhesion. And then as far as dry adhesion is concerned, we have discussed how it works and how it's biomimic. This is the overall schematic structure of such kind of movement. And then these are some of the models which are involved with reference to Gecko inspired climbing robot. Now there are certain amounts of models which exhibits. So like one of the model is with reference to this pressure plate. The other model is with reference to an elastomeric adhesion, and third model is with reference to an electrostatic adhesion where we have a plate and then we have a movement which is being kept over here. Then we have a kind of a thermoplastic adhesion which exhibits, and then there is a kind of, we have also discussed about the different locomotion mechanism which persists. So one of the locomotion mechanism is a kind of a legged climbing, a rolling or a sliding motion, and a kind of a suction or a gecko based hybrid motion which exhibits over here, basically for some kind of hybrid climbing related applications. We have also discussed about some of the commonly used material which is used for gecko inspired material for adhesive related systems, and then we have also discussed about the kind of a different fabrication techniques which are being employed for this gecko related applications, and these are the applications and these are the challenges related to the gecko inspired climbing robot. So we will also discuss about this some of the other case studies with reference to such kind of system. So we will be discussing about this magnetic swimming based micro robots and its applications in the upcoming lectures. Thank you.